we are discussing about derivatives. What is a derivative? So specifically, we will be talking about derivative at a point. What does it mean actually? How do we define this? So as a definition, a derivative at a point is just a limit. Derivation or derivative at a point is just a limit. So what does it mean mathematically? So let us assume that there is a function fx and this is a real valued function. That is, it is defined in certain interval, certain domain, and this interval in this which it is defined. So whatever you give between a and b, you will get a value of y if you put some value of x in between a and c. So let us say this x which you are putting in fx is c. C is belonging to a comma b, and this is an open interval. So we are talking about function, and this fx is said to be differentiable or derivative. What is a derivative? At some point c. For example, you have a domain, so say an interval from 2 to 5. You take a value 3 in between. Now say some function y equals sine x. Now you want to put sine 3. So you are going to get a value of y. So then you'll say this function is differentiable or derivative exists at x equal to c, that is 3 here. So this function is differentiable if and only if the condition is what? The condition is limit. Limit must exist. For example, limit x tends to c, for example x equals 3 here, fx minus fc, that is, well, taking the value of fx and then the value at particular point 3 in this case, and x minus c. So this limit should exist finitely, and then we say this fx is differentiable. It is existing finitely. So this limit is called as derivation, derivative, or differentiation of this function fx at some point x equals to c. If it is giving some 0 by 0 form, you can take the limit. If it is okay, then you say that this is the derivation. This is the only derivation. We will talk about its physical, interpretation, etc. But basic is derivative is this only. It's only the limit. It is only the limit, nothing else. So let me take you to the different notation of this fx, f dash x. That is, this whole bracket inside is f dash c. This is a representation. Dash represent derivation. Then you can also call it as capital D of fc, or also call as d by dx of fx. And what is fx? Y, as I just took. So dy by dx at x equals c. So if we have any differentiation, essentially you are doing what? This f dash c, that is value of this fx at some point c, is limit x tending to c and fx minus fc by x minus c, right? So when we say that this is 0 by 0 and we have changed it, or we are able to show that it exists, there is no formation indeterminate case, then we say this is the derivative. So in this whole discussion, we will say that this is fx function is differentiable, that is in this certain domain, it's differentiable, and this limit will take it as, when we discuss limit, that is the left hand limit has to be equal to the right hand limit, and it has to be equal to the function at that particular value, right? So we say c minus we will take, c plus we will take, that is c plus, sometimes we will put c plus h, other time we will put c minus h, and then we will try to equate and we will say it is equal. Then we say that the limit exists. As I am saying, c plus c minus is exist, x plus h sometime, x minus h sometime. So this limit we have already seen. But this limit we are applying, and we are saying it that this fx minus fc by x minus c is there. That is your differentiation. Okay, I'll tell you an example. Let me tell you an example, and then you will understand what we just discussed. Okay, so we have, see, we have a function, say fx, and this fx function is x square plus 1. Now, as I said, you have to have some c value, that is some value, value in the range domain. So you have 2. So you have to find out the derivative or derivation at f2. So f dash 2 we are going to find out. As I said, it's just essential limit. So you say c plus or c minus. So let us take c plus. Okay, we are going to put fx minus fc by x minus c. This I already told you. You have to apply limit x tends to c. In this case, c is 2. C is 2. So x tends to 2, and I'm doing it for 2 plus. That is 2 plus h I am going to put. So in place of x, you are going to put 2 plus h minus fc, of course c is 2, and divided by 2 plus h minus 2. So this is x minus c. In place of x, I am putting x plus h. So this is extending to 2, as I said, extending to c. But since we have put x as 2 plus h is tending to 0, because x minus 2 if you take, and if you say that x is equal to 2, h is going to be 0. So limit h tends to 0 now. Now what are you going to get? Wherever you have this 2 plus h, in x, replace it by 2 plus h. So 2 plus h whole square minus f2. So f2, you have to put, in place of x, you are going to put 2. So 2 square plus 1. I'm just replacing this x with 2. So 2 square is 4, 4 plus 1 is 5. And this is 2 plus h square plus 1 also. There is what plus 1, I'm just going to add this. So you have h square, I'm opening it, a square plus b square plus 2ab formula. So h square plus 4h plus 4. This is also plus, I'm just going to change it. So a square plus b square plus 2ab, and also plus 1 also. So what do you get? A square plus b square, is 2 square, that is 4, plus h square, that is h square, and 2 into 2 into h, 4h. So 5 and 4 plus 1 gets cancelled. So h square plus 4h it is. Now h square plus 4h, I'm just going to change this plus. So h square plus h, now you can take h common, and then h can get cancelled. These are all plus, as I just said. So this h gets cancelled, you have h plus 4, and now you apply the limit here. Limit is h tending to 0, so h is going to be 0, and 0 plus 4 is 4. So you are going to get the value, this is f dash 2. F dash 2 is 4, that is differentiation of this function at 2 is 4. So what are you going to find out? In f dash, you are going to find out d by dx, dy by dx, and y is fx here. Okay, then what you have done, you have just done the limit, you have taken the limit which is extending to 2. For what? f2 plus h minus f2 divided by this x minus c, as I indicated you earlier. So this is the derivative at a point. It was 0 by 0 form earlier, but we proved it that it is not 0 by 0. We have a proper limit here, left hand limit, right hand limit, and that is going to be 4, and that is the differentiation value. Okay, and we'll see the physical interpretation of this derivative at a point. Okay, till then, thank you so much and take care of yourself.